Welcome to Station 3. At any given time, there will be up to 4 groups at these 2 tables. This is the actual station where you use the microscope and manipulate it. Now, Miss Vagler will be walking around these 2 tables especially. Do not touch the microscope until told to do so by this video. Please follow all directions carefully. These microscopes are $1,000 a piece. You do not want to be the one who breaks it. They are set up very, very carefully at the table. Please don't move them around. Don't pass them back and forth. You move to the microscope doesn't move to you. All right, you should be in parts 2, 3, and 4 of your Introduction to Microscopes paper. We're going to start with part 2, the eyepiece. You may pause and rewind this video as needed. Now, what you're going to do now is you're going to move the eyepiece and you're going to look through it. Now, I want you to look through it 2 different ways, and I want you to make some observations and just write them down. Okay, so you're going to look through it with the lights off first, and then turn the lights on and look through it. And make sure everybody at your table gets a chance. Don't push the microscope back and forth. Move over so that people can move to the microscope. That's how it works. Okay, now, pause the video, make your observations. All right, I'm going to tell you what most people notice. Most people, the first thing they see with the lights off is just darkness or their eye reflecting back at them. Because there is a mirror at the bottom of the microscope, so some people will see their eye reflecting back at them. When you turn the lights on, what you'll notice is this beautiful needle, also known as the pointer. Okay? When you look through the microscope, there is always a little pointer because you want to be able to see things. Okay? Now, the pointer does move. If you just saw my little spinny thing, it does move because you can, when you rotate the eyepiece, you will notice that it moves. You have my permission at this time to rotate the eyepiece and test that out. Okay? And that is so you can use the pointer to point at stuff that's really small. Okay? Because tiny things can be pointed at, but tiny things cannot be pointed at with your finger. Okay? It doesn't work. LOL, you can't touch this, says the tiny microbes on the slide. Because when you're pointing at the thing with your finger, nobody else can see it. Use the pointer inside the microscope to point out what you want to talk to other people about. Nobody can see your finger. It's not microscopic. It's too big. Use the needle that's microscopic. Thank you very much. Now, you should know the power of the eyepiece by now. It's 10. 10 times what you see with the naked eye. Okay, that's the power of the eyepiece. So the next thing we're going to do is look at the objective lenses themselves. I prefer that you look at the actual one on the table, but if you cannot see the actual one at the table or you're afraid of breaking it and don't want to stress over that, you can look at the pictures that I have of it in the video. Notice that they are color-coded so beautifully. There is a red, yellow, and a blue objective lenses, and they are color-coded by size. It goes smallest, medium, and largest. So fill that out in your chart. It should say red, yellow, blue, small, medium, large. I would color it so that it helps you remember. There will be a quiz at the end, and I suggest you do your best to remember as much as you can now. Next thing you'll notice is there's something called a DIN number, D-I-N, DIN number, and it is the first number on the objective, not the second one with the decimal point. It is the first number, the one that says DIN number is the DIN number. Okay, and this tells you the magnification of each of the lenses of each of the objectives. So the smallest one for us, the red one, is 4, the yellow one is 10, and the blue, the largest objective that we have, is 40. So you will want to fill that out on your chart, 4, 10, and 40. Okay, those are the magnification numbers, the DIN numbers. Now there is another number that is very important for the lens constructing people. and that is the number with the decimal point. Now, I'm just asking that you write it down so that you can differentiate between the DIN number and the decimal point number. The decimal point number does not tell you the magnification. The decimal point number is special for the manufacturers of the lenses. Okay, so you will notice that for the red lens, it is 0.10. For the yellow lens, it is 0.25. And for the blue lens, it is 0.65. Notice that for each thing, it gets progressively larger as you go from the left to the right. As you go from red to yellow to blue, it gets progressively larger in each thing, in DIN number, in decimal point, and in length of lens. Okay, that is important to notice for things like storage and for when you are adjusting the microscope so you can see things. Okay. Pause if you need to so you can fill out your table. Okay, the next table is about microscope power. Now, when we say power, we mean total magnification of the microscope. We mean how much is it magnifying what you're looking at? Like, we can look at it with the naked eye, and then we look at it with the microscope. How much different? What mathematical multiplier are we using in between the naked eye and what we're looking at through the microscope? That's all it means. Now, there's a really easy way to figure this out. Okay, you just take the DIN number, which for us is 4, 10, and 40, and you multiply it by the power of the eyepiece. The power of the eyepiece is always what? You should know this. Try to guess it without Miss Fackler saying it. Okay, you should have figured it out by now. It is 10 times. The eyepiece is always to the power of 10. If you just took the eyepiece off and looked at stuff through the eyepiece, it would magnify stuff 10 times what the naked eye sees. Okay? If you took the objectives off, it would be 4 times what the eye sees. It would be 10 times what the eye sees, or 40 times what the eye sees. Okay? That's if you took the objective off, which you are not going to do. Okay? And then it's the easiest form of math ever, and you should be so happy it's the easiest form of math ever. It's just multiplication. Yeah. So, all you have to do is multiply the DIN number, so the magnification of the objective, by the magnification of the eyepiece, which is just multiplying by 10. So it should be super easy, and you should get 40 times is the magnification for the smallest lens when you use it. 100 times is the magnification for the yellow lens when you use it. And 400 times is the magnification for the blue lens when you use it. So that's nice and simple. Nice and simple. What you're going to do next, if you've already filled everything out, is you may practice setting up the microscope. I want each person at the table to practice turning it on, turning it off, and adjusting for focus. Now, we'll get to look at other things under the microscope on Friday when we do our microscope images lab for funsies, and you'll get to look at a lot of really interesting things on that day. So I don't want you sticking a bunch of stuff under there. No, you can't stick your pencil under the microscope. That is not acceptable. If you color on it, yes, I will charge your account for the school $1,000, and you will have to pay for that damage to the microscope. Okay? So I want you to practice setting up the microscope, practice looking at the microscope, practice swiveling the eyepiece of the microscope. You need to be very, very careful. These are $1,000 pieces of equipment.